Hello explorers and welcome to another video. Today we're doing more Advent of Code. Let's jump right into it. So, your ferry has decent progress towards the island, but the storm came in faster than everyone expected. The ferry needs to take evasive actions. Unfortunately, the ship navigation computer seems to be malfunctioning. Rather than giving a route directly to safety, it produces extremely circuitous instructions. When the captain uses the PA system to ask if anyone can help, you quickly volunteer. The navigation instructions or your puzzle input consist of a sequence of single character actions paired with an integer input values. After starting them for a few minutes, you can work out that the probably mean north, south, east, west, left, right, forward, and left, right is given in degrees. The ship starts facing east. Only the left-right actions change in the direction of the ship is facing. That is, if the ship is facing east and the next instruction is north 10, the ship would move north 10 units, but would still move east if the following action were forward. So for example, and they have some information there, and then you need to calculate the Manhattan distance, so that's the east-west position and the north-south position, and you add those together and you get the Manhattan distance. So this is pretty straightforward, and I think we can solve this. If we jump over here, I have prepared a little bit of a puzzle input here. So first off, I think we need to have a regular expression. Pattern compile. So I think that we need to handle this north, east, west, south news. Left, right, forward. So those are the letters that we expect. And then we want digits, a couple of those. So let's see here. That's what we are looking for. And if we take this pattern and we do a matcher on the line, and then we get a matcher back, and then that matcher, when it finds something, we will run a function. So let's say that change handle instruction, and it takes the matchers group 1 and the matcher group 2. So that's the instructions that we want to handle. Create that method. It gives us a string, which is reasonable. And the second one we know is an integer, so we can do an integer parse int of that. So we actually get the int value here instead. So this is direction, or instruction, and this is value. So now we want to do something there, handle this instruction. So what we need a couple of things. We need an int direction, and let's set that to 0. So that's our eastwards. Then we can do, let's see here, private, let's see here. Yeah, that's the direction. And if we do like this, that we have You can start at 90, but because it's easier to think about it as 90 degrees. Then we can say that this final int here of north is 0. And we can do a few of those. So east would be 90, south would be 180, and 270 would be west then. So we can have those directions ready to go. And then we can have a position where we can say that we have an x value of 0 and a y value of 0. So that's the current value there. And then we can take this instruction and switch on it. So if we get the different cases here, we will do different things. So if the case is, for instance, north, we'll do something here. So we can either do that, or we can do a break here. I think we do the break. And if it's north, we will take the value and take y minus the value. So that's pretty easy. And I think all these need to be static as well, because we are working in a static context now. Let's do them as statics. So there we go. And we can do a couple more here. We have the south, which adds to the y. We have the east, which adds to the x. And we have west, which decreases x. And then we have forward, and that is depending on the current direction. So we can do another switch here, or we can move forward and then the value. So that would be the easiest way there. And then we can have the last case here, which is, or the two cases here, left and right. So this is, left is minus, so change direction. So that's minus value. And then we have right, which is a positive value. So there we have change direction. So the change direction would just take the direction we have and add the value to it. And if the direction is less than 0, we will take that direction and add, let's see here, 360 to it, right? And if the value is more than 359, we will decrease it with the same value. So that means that we can handle when we are flipping to lower or higher values in the direction. And here we will have a switch statement. If the direction is a case of 90, we can do 0, we will have the same values as here. So we can just do like this and then change these up to north, south, east, and west. So that's pretty much it when it comes to this. And then here we will take system out, Embry will print the Manhattan distance, and that's equal to x plus y. And here we need to do math absolute as well, because the minus values are still distances from the center. So that could result in something good. I'm just writing a bunch of code here and just running it. Could be good, could be bad. So here we have F10, no group 1. Okay? That's interesting. Oh, we need to have parentheses here so we actually get groups as well. That's reasonable. So let's see here. Now we got the Manhattan distance of 25. Let's go back and review. 25 was the right number. That's really cool. I just wrote some code and on the simple example, it just worked. So let's see if it actually works on the more advanced example. That 1007 could be. It seems reasonable, so let's try it. You get a gold star, I get a gold star, everybody gets a gold star. We just wrote some code and it worked on the first try. That was really fun. And I think it's very reasonable as well. So we have something that will take out the line and figure out the different patterns that could occur. We give that to a handle instruction. The handle instruction will just parse the letters and decide what to do with the value. And then we will have a function to move forward, which will handle the different directions that we have, north, east, south, west. And we also have a change direction that will change the direction depending on the degrees we want to change it. So it seems very reasonable that it should work, and it did. So next up, before you can give the destination to the captain, you realize that the actual action meaning were printed on the back of the instructions the whole time. Almost all of the actions indicate to move a waypoint which is relative to the ship's position. Okay, an action N moves the waypoint north by a given value, south by a given value, east by a given value, west by a given value. L means to rotate the waypoint around the ship left counterclockwise, and R means a waypoint right counterclockwise, and F means to move forward to the waypoint a number of times equal to the given value. The waypoint starts at 10 units east and 1 unit north. Relative to the ship's waypoint is relative to the ship, that is. If the ship moves, the waypoint moves with it. For example, giving the instructions above, 10 moves the ship's waypoint 10 times, a total of 100 units east, and 10 units north. Okay? Leaving the ship at east 100 and north 10. The waypoint stays 10 units east and 1 unit north of the ship. N3 moves the waypoint 3 units north to 10 units. And let's see here. N3 moves the waypoint 3 units to north, 10 units east. 10 units moves 3 units north to 10 units, and east to 4 units north of the ship. The ship remains at east. F moves the ship to the waypoint 7 times, a total of 70 units east and 28 units north, leaving the ship at... So just parsing this is the hard part. So, the waypoint starts at 10 units east and 1 unit north. Okay, that I understand. And then we move 10 times. So we will move a lot in that direction. That is something that I can wrap my head around. N3 moves the waypoint 3 units north to 10 units east and 4 units north of the ship. 3 units north. Okay, so it stays at 10 units east and 4 units north of the ship. So we change the waypoint there and the ship remains at its position. And then when we are doing the F7, it moves by 7 for the different, so 7 times 4 and 7 times 10, and that will move the ship. Okay, so let's get back to our code here. So now we need to have a waypoint, private static int waypoint. I think we can actually keep this because this will be something totally different. So let's keep it and create a B example here. So first off, we need to have the waypoint here. And it should be XY waypoint. And it should start at 10 east, 1 north, right? And in our case, north is minus value. So that's what we want to accomplish. I don't think it really matters, but just to make it simple for ourselves, we are still rotating. So the rotates the waypoint around the ship 90 degrees, moving to 4 units east and 10 units south. So let's see here, 90 degrees. Before we had 4 units west and 10 units south of the ship. So when we rotate it, we move them clockwise. Okay. So I still think that this applies here. But the difference here is that we will take the waypoint y times the value. And here we will take the waypoint y, waypoint x, and waypoint x. So those are the movements. No, those are not the movements. It's just the forward that will do that. So let's do this on the forward. So that will change the forward direction. Here in north, we will actually do the same thing that we did before, but we will do it with the yx and wx and wy. So we will move the waypoint, the different values here instead. So that's what we want to do. And here, if we move forward, yeah, so when we want to rotate here, this is the difficult part. So let's see here. If we can have 3 different outcomes here, right? In different directions. We can actually have the value. Okay. switch a value. And we can have minus 270 all the way to plus. I don't think we will have a 0 in the middle here, so 90, 90, 180, 270, 180. So let's break here. I will keep this function. So if we want to move backwards that way, that much, and we have a waypoint, want to always do these two, right? So now it's the hard part to figure out how the direction changes depending on how much we rotate. So if we are at 0 and we rotate 90, let's say that x yx is equal to 9 and y is equal to 1. What happens with these values? We want to rotate them, and let's copy this one and see if I can figure this one out. So here we started at 10 units minus 4 units, 10 units to the east. And then we wanted to end up at, the only thing we can do is if it's less than 0, we can add 360, and if it's larger, because those will be the same actions, right? It doesn't really matter in what way we are changing this. So here the yx would be equal to minus yi, because that would be make the eastward direction correct. So we will switch those over, and y would be yx, just like that, right? And in this case we will just switch them around, because we will move in the opposite direction. And I guess that this will do that. Seems reasonable. So let's try this out and see what we get. Let's try that out and see what we get. 440. And they thought it was much less than that. So that doesn't really work. So let's see here how we did. So let's start by handling this instruction here. And we start there, and we have a forward as our first command here, 10, yes. So we moved the forward, and that moves x to 100 and y to minus 10. So that's right. That's what we were expecting. So the next instruction is north. And that will just change this to -4. And that's what we were expecting too. Then we will do a forward operation. And that will give us -38, 170. And that's right as well. So now it's the rotating part. That's the hard part here. And when we rotated this, what did we get? 14, 14. Yeah. Of course, of course. So we just need to have another variable here, so we can do the switcheroo. That's important. So yx, so we don't set them to the same value. So that's more like it. 396, it's still not correct. Okay, so let's debug a little bit more here. The first one was easy, that was easy, that was easy. Now the rotate 90, and we get here. So first off, we take that value and we set y to x to -y. Yeah. We want to change direction, not add or minus the specific direction. Let's try it again, see what value we get now. 286. So let's see here, 286 was the correct value. So we had a couple of bugs in this, but they weren't that hard to figure out. It was very simple bugs. And if we do that, we get a value of 50,634. Let's see if that's the right value. No. The answer is too high. Okay, so we did something wrong here. Let's see if we can figure this one out. This rotate function makes things a little bit harder. I wonder if the easiest way to do this is if we can use the Java vector rotate in some way. So let's see if we can find Java rotate vector. Let's see if we can do that. Some functions to rotate. So these are the rotating functions that they suggest for an angle. So let's see if that works. And the angle is what? So let's say that we have these two functions here. The angle is the value. And then we have yx like that. Like that. And the new values will be new x, new y. See if that is the correct values after one rotate here. See if that works. Now we have values The old ones were -4 and 10. Not really the correct thing here. See if we can search on Java math cosinus. Okay, equals degrees. So we need to have them in radians, of course. So let's go over here again and do float radians. That's our value. Then move these over here and see what we get. 2 radians. Double, okay. We can do that. Double. And stop that and see what the new x becomes here. So this is much more reasonable. And so we can easily use these new values as vx equals to new x. If we do that to an int value, and we use the same for y. And hopefully that will work. We could probably use the okay, double radian equals to math to radians value. Don't know why that disappeared. So let's try that and see what we get. We got the right value. Let's see if we can do the same with our real example here and if we get a different outcome. That's the important part here. We got a smaller value, which seems very reasonable because they said that our value was too high. So let's try the smaller value. So now I've used the power of Java and hopefully this will work. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. We completed day 12. I hope that you found this video interesting. I learned a bit today. Don't try to do vector math by yourself because that will end up in disaster. If you liked this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you have any comments or suggestions, leave them down in the comment section below. If you have tried it yourself, leave some code down there. And I really hope to see you in the next video.